Okay, so in this video, we want to review two simple but fundamental trigonometric identities, and they are both derived from Pythagoras' theorem. So let's first recall this result. So it starts with a right triangle. Let's label the sides as ABC. And all it says is that the base of the triangle squared plus the height of the triangle squared is equal to the hypotenuse squared. And this is true of any right triangle. Well, let's see how this may apply to the trigonometric functions sine and cosine of theta. So in this case, as we discussed previously, we take a right triangle with a hypotenuse of 1. Let's call the angle at the base theta. And as we've discussed previously, for such a triangle, the sine of theta is the height of the triangle, and the cos of theta is the base of the triangle. But Pythagoras' theorem applies to any right triangle, so we can apply this result to this triangle. So we have the base squared, so cos squared of theta, plus the height squared, so sine squared of theta, is equal to the hypotenuse squared, but 1 squared is simply 1. And this is our first fundamental trigonometric identity that exists between sine and cosine of theta. Cos squared plus sine squared equals 1. You may see it more often as simply adding up these two in the opposite order. Sine squared plus cos squared is equal to 1. And this is true of any angle theta. And again, this is a simple consequence of the more general result that is Pythagoras' theorem. From this identity, we can obtain another fundamental and very simple identity that involves not the sine and cosine functions, but the tangent and secant functions. So before we derive it, and it will take just one line, let us recall how to obtain the tangent and the secant function from the sine and the cosine functions. So if you recall, the tangent function, again by definition, is the ratio of the opposite over the adjacent. But if you look here, the opposite is sine, adjacent is cosine, so the opposite over the adjacent is sine theta over cos theta. And the secant function, well, the cosine is the, again, adjacent over the hypotenuse. The secant function is the inverse. It is the hypotenuse over the adjacent, so it simply is 1 over cos theta. And now we can derive the following identity that involves tangent and secants. If we start with this one and divide the left and the right side by cosine squared. So we have, let me rewrite it, so sine squared of theta plus cos squared of theta is equal to 1. And again, we have an equality, so as long as we divide both sides by the same thing, we preserve the equality, and we divide both sides by cosine squared of theta. Well, let's divide now both terms on the numerator by cosine squared. But if you think about this, what we get is quite nice. Sine squared over cos squared is just the sine over the cosine squared, but sine over cos is tangent, so this term over this term is this squared, therefore tangent squared. Plus, well, cosine squared over cosine squared is simply 1. So on the left we have tangent squared plus 1 is equal to, and well, if by definition secant of theta is 1 over cos, well, if you square the whole thing, you get secant squared. And usually people will write 1 plus tangent squared. So again, we do the same thing we did before. We flip these two terms. So 1 plus tangent squared is equal to secant squared of theta. And this is the other simple but fundamental trigonometric identity. And that's it.